Hi guys, subscribe to my channel, leave a comment, and wait a second, it's better. Um, Leave a comment, subscribe to my channel, put like button and share this video among the world. And right now I will go wash my glasses, wash my teeth, dress my t-shirt, and we'll come back soon. So be tuned, stay tuned. Okay, so first thing I want to notice is that uh, on my second monitor, I mean not primary, there is nothing, so you cannot see even the time. So for example in Windows this is not the case, so yeah, just wanted to mention it. And yeah, I will launch my PDF right now that we will look at, and it is called advanced blah blah blah. So yeah, and basically let's go through it, okay? Um, so we will go through it fully, okay? So yeah, so here is a basically preface, so we can go to chapter 1 and just go to some code. Okay, so here is the first code of this book. It includes some header, then includes dir entry.h, creates a structure for a dir, structure for a dir entry, then it opens dir that we passed and saves it into dir. Also it is using error system error, which is adding a um, it is adding these messages. Okay, and while we read from this directory, so we read something in this directory and save it to dir entry, and while we read it we print its name. Okay, then we close our dir. Okay, so pretty easy. Okay, we define some number, we create a array of char of this number, and then while we read from um yeah, so this is stdin, so I guess basic input, and we save it to our buffer and write to stdout our buffer, and when it's not written we can say write error. uh, yeah, and also here we say read error when we can't read. Okay, pretty simple. um okay, here we get char. We get char of course from stdin, and while it is not the end of input we put char to c. No, we put our c variable to stdout, and yeah, and also we use f error for if there was error on stdin. So quite the same program as previous. Okay, this one it's printing, it's getting bit of itself, I guess, right? Yeah, so here we're including something new called system weight. Again, we create buffer, right? Create bit, create status. We print. Wow, what is it? Print prompt. Print requires print. Okay, then we get some characters from input into our buffer. Then if it's if we read a buffer that contains like enter on the end, so if it is the whole stuff that user printed, like maybe he printed like more than a buffer, right? So it is the whole, so then we replace this enter by end sign, and then we create a fork from this process, right? So if fork failed, we say fork error. If bit 0, which is crazy, right? How fork can be 0. It's very crazy. Exec lp buffer buff. What is happening? Okay, first I don't understand what is fork. Yeah, the problem is that I don't have internet right now. So what can we do in this situation? Let's just try man fork. Mm, return on success the pit in the parent and in the child. Okay, so 0 on success the pit of the child process is returned in the parent and 0 is returned in the child. Ah, guys, I think I got it. So we have a parent and we have a child, okay? So this one is creating a fork, right? Um, right? So imagine we have a main program, it creates a fork, but then it will like actually those forks, those children will actually invoke this also. But for them, the speed will be equal to 0. Okay? Okay, so it looks like we cannot fork from a fork, right? Okay. Uh, and what's next? So if this is a child, exec lp buffer. Okay, I don't know this command, but I guess it's executing the buffer, right? And what's not? Ah, okay, I got it. So this command is basically executing the command and buffer, and after this command we will not do anything because exec is basically substituting our process on another process. So after this command we will jump to this function and will never come back. But if we end up here, this means that we failed to execute, okay? And if bit is wait bit state 0 0 wait bit error. Okay, what is wait bit? Wait for process to change state. So when it's okay, return. What is return? Return variable. So -1, so on failure. Okay. On success, return the process ID. If Pete status. What is status? Oh, status. Okay. Um. Mm, wait. If Pete. So basically, if this is in parent and we wait Pete and on success returns the process ID of the terminated child. Okay, so anyway, we just monitor our children with this. Okay, nice. So this is basically a shell, right? Nice. Yeah, so here you can see we execute our programs and we have some prompt and we have date, who, nice. What is this one? So we have something called Erno. Number of lost error. Okay. So also we have this function that is actually going to it as a string, and here we have p error. Anyway, so we include this error now. We print on error output something. For example, this error, and this is predefined macro from here, and stringify it, error number entry, peer given 0. Okay, this is okay. So here, what we do, we get UID. What is the git, by the way? Uh, get group identity. Okay, group ID. Okay. Okay, so we add some functions that we are defining here, which is basically printing interrupt. Here we're adding if signal sig int. Okay. So this is some sort of callbacks, right? So on this signal we execute this command. Okay, nice. Okay. Okay, we grab something. Okay, I hope here will also be some code. Okay, it's talking about some macros. Okay. Okay, this is AVK script. Yeah, AVK. Yeah, the cool stuff that it has printf. Wow, it's actually doing some C code, but I don't want to go through it, to be honest. Static void, some. No, guys, sorry, but it's too bad for my eyes. Okay, so if define print, otherwise print, otherwise peer. What is this one? Well, wait, this is our function, right? Anyway, let's check. Yeah, it's some custom stuff. Okay, so here we have a normal program. Okay, we define some two functions. This one is strings long puts string twisted out. Gets passconf, which is what actually? Get configuration values for file. Okay, so basically, so if name corresponds. So yeah, basically it's just what does it do? Passconf gets a value for configuration. Gets the value name for the file. Gets a value for configuration option name for the file name path. So we get the file path and we have option of its name. Okay, I got it. If we failed, not supported, otherwise something with pass, else no limit. Basically we're okay, this is not an error. And then we get the value. The value is basically return statement of the what we are searching for of the parameter. Okay, this function is wait, it's pretty same, right? Puts some message. Okay, then it's executing this command. Get configuration information at runtime. POSIX allows an application to test at compiler run time whether certain options are supported. Okay, so we get some values. Okay, so we can get like maximum length, maximum number of per process. Okay, so it's like system values, okay? So we get this, we say not supported, blah blah blah. Otherwise we print it. Okay, nice. Okay, I required something new. It doesn't even here. Okay, maybe it's here. Print our argmax defined, and here we say argmax, which is basically is from here. Maybe if we say no symbol. Wait, what? Yeah, okay. If defined, we get argmax from system. Otherwise, we get no information of it. Yeah, and similar stuff for the next one, so max canon. Yeah, and that's all, guys. So pretty easy. Here is a list of the stuff. Argmax, for example, and something canon. Maybe. Okay, nice. Okay, passmax. If it's defined. POSIX version XSR beta lock. Also allocated size if no. Creates pointer size. X if POSIX zeros and POSIX version get version. XSI version zeros and get it. First time through if passmax equals it's 0 and it is equal 0 if this one is not defined. Pass max, pass conf configuration of this one, getting pass max value. Okay, so we successfully did it, else we did not did it. Else we go else. Okay, so this is strange, right? But this is the implementation of this task, of this function. If POSIX is less than and XCI less than size pass max plus 1, else size is plus malloc, and yeah, size p, and return pointer to the. Okay, and also uh, we pass here this variable. Okay, no problem. Okay, no file. What is no file? Can I search for it? Okay, no file. Okay, so number of files, right? Include sysconf sc openmax. So yeah, for the files that I closed, it's interesting. So they're getting from 0 all files. It's nice. Okay, we get openmax. Openmax guess is 256. Openmax is we try to get it. Basically, we return it. Okay. Otherwise, we guess. Okay. Okay, so this book is definitely good for searching stuff. So you can, for example, search for some variables and find it here. Okay, so here we just define variable. Okay. Okay, what is C99? Is GCC. Okay. What is CC? Okay. Um. Okay, some difference, of course. Okay, we have two functions, open and openat. What is openat? I mean, open, it's easy, right? Okay, and openat. Okay, too hard. Um, both return file reciprocal. Okay, so you can use both. Okay. Create. Wow, this is really. Why not create? Okay. Oh, okay, okay. So creating a file is easy. What is lseek? Okay, so we can set offset and it's easy. So we set offset of std into 0. Cannot seek OK. So here we launch this seek OK. Why here we cannot sync? Maybe because we use a pipe. Here we cannot sync because we are doing this from some device. Okay. Okay. Creating file, writing to it, seeking. What? Why seeking? Why seeking? Sorry guys, I did not understand. So what will happen? Hmm, it will fulfill nulls. Okay, got it. Read. Okay, it's easy, I think. Write, I think also easy. While and read from stdin, and we write to std out. Okay, so basic get program, right? Nice diagrams. Atomic, really? Okay, position. Oh, okay, to end of file because this is from end, right? Okay, right. Pread. A single Unix includes the tell applications to seek. Okay, so here is pread and prewrite, which is atomic, right? So this is because of multi-threading stuff, right? Create. Dup. Why do we need to duplicate? I don't know, maybe we have some threads or something like that. It's quite hard, you know. You should read it, I think. What's F-sync? Okay. So it actually flashes, right? Quite same for me, I don't know. Okay, change properties. Okay, so we get to input, we change properties, right? Of this one, get a file. So we cannot change the properties of this file. Then we switch this value we got with some mask that gives us some interesting stuff, and this one is read-only. Right, so this one actually is reading property, right? Read only, write only, and read write, okay? Unknown access mode, okay? Error dump. Yeah, it's core dump or what? While append, non-blocking, sync. If some stuff is defined, synchronous writes, okay. If not defined, okay. So here we get read-only for TTI. This is strange, right? Because TTI is terminal. Write only. Okay, so one is write only. One is write only. Maybe because it doesn't exist. Write only append. So what is actually happening? Okay, I think I got it. So we actually here what we are getting is this file, right? And we say write only and append because we use this statement. Read write. Okay, so we both read and write from this file. I don't know what this first stuff is doing on. Oh, descriptor. Okay. But why does it changes? And doesn't matter, right? Flags are file status flags return on. Okay. If value, if we get like get file, if there are some flags, then we set those values. Okay, so basically this is setting of flags of a file. If we change the middle statement to turn flags off. Okay. Okay, nice. Synchronous, right, like, okay. And here is some statistics, okay. So the best one is this one. And also some statistics. The best one is write to def null. Man is pretty confident. EOCTL function. Anything that couldn't be expressed. Okay, let's check. Control device. Okay, that sounds cool. System call manipulates the underlying device parameter of special files. In particular, many specified terminals may be controlled. The element within must be an open file descriptor. So we pass some file and then we send a request. Dependent request calls server. Okay, so it's device, to be honest. Dependent stuff. Oh, class names. Okay. Okay. So there are some numbers of stuff we can do with socket, right? Okay, so this one is descriptor stuff. So we can open some file. What is stop? Duplicate, right? Open. Read write. Filter. Okay. What is filter? Caps file conversion filter interface. Okay, something I think where was here cat file minus. Oh, okay, it's just it's just a minus, and we're printing it. Okay, okay, it's some stuff is. Okay, start statistics, file statistics, uh, L statistic F. Okay, we'll. Okay, and here is the file statistics, right? Or not file, I don't know. User group, yeah, it's file statistics. Device number, okay. Um, some macros. Okay, so what do we have? Is a stat buff. Okay, so we go to we get some values from our command line and we basically get stat and we basically check if stat is registers and it's regular. Oh, okay, it's in regular file. If this one in directory, if this one blah 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 blah, and we print it. So here we see that those are types of files. Okay. What is the statistics? Okay, this is like okay. We can set some user IDs and group IDs. I think it's obvious. File permissions, ownership. Okay, what is access? Uh, okay, so it's basically do we have access? Um, okay, so we try to access in, and we can have an access to open it. Okay, so it's getting access again. Access, okay. Okay, this one is root, so this one is not accessible. Okay, I got it. Okay, some umask now we can describe the file mode creation mask that is I mean, yeah, we can, why not? But wait. What does it do actually? Previous file mode creation mask. What's C mask? Okay, let's see. So you mask 0. We create a file. You mask we pass some flags and then we create another file. Mm, you mask. You mask 00 to print the current file mode creation mask. Okay. Okay, so current. So when you create a file, there is the current creation mask. Blah blah blah. So now, see if the file mode creation mask has changed. Out. Yeah. Okay, foo. Okay, wait. So we created foo and bar, right? So first we create foo with the default mask, and then we change it. We change it to this one and create this one. Okay, seems good. So even we pass here something, it doesn't matter because. Okay, nice, nice. Yeah, so 002 is our other right. Okay, no problem. No problem. Okay. Symbolics, okay. chmod, and okay, so this is basically command that change something like chmod plus 6, right? We can get some start, then we chmod this file to start buffer start mode, and we pass something like x group. Okay, so definitely you will need to understand what those constants mean. Chmod error for full. Okay, so basically, yeah, which mode we change mode of the file, right? Wow, it's like 40 minutes, nice. 40 minutes and we are here, so in theory we should have 1, 2, 3. Wow, we have a lot of to do. We need to speed up. Change owner, right? Change owner stuff, so it's also accessible through C code. File truncation, okay. Sometimes we would like to truncate, okay, no problem. Okay, here is a cool diagram. Link it, unlink it, and remove functions. Okay, I will just look at what is link. Man, link. It's ln, right? Call the link function. Okay, no problem. So we open file, we unlink this file. What? Unlink, print file unlinks. What does it do actually? So we have some file. We say that I don't know how many usage. We launch our program in the background. Why in the background? Because it's sleeping. Okay. Um, and now what? File unlinked. Okay. Is still there no such file or directory? Wow, guys, it's basically deleting, right? But the size stays the same, right? No? I see, guys, I see. So it's temporarily unlinking the file from the file system. Okay, nice. Remove, of course, it removes. Okay, rename this is easy. Okay, this is diagram showing how it works. Symlink, symbolic link, right? Yeah, so link is not actually a link that symbolic link, right? Read link, okay, so we can self and read the name because the open function follows. Okay, so open is following, but if we want the link itself, we need to read link. Okay, seems good. So we need to change this link and then first open it. Okay, so here is the function. Okay, we have pipe. That's great, right? Few time. Several functions to change access time. Okay. Okay. Uh, Seconds, microseconds. Statistics to timestamps for argc. We fetch current time of some file. We open that file with basically truncate. Wow. We create some times. Then we set our files to and close it. Okay. Why do we need truncate? I don't know. Maybe because it's how times are needs to work. Here we see. Okay, just here we see that it's changing actually, right? Okay, make dir is pretty easy, right? For reading directories, there are a lot of stuff. Okay, what is tell dir? Okay, in the stream, what? What does it mean in the stream? Okay, I don't know. inode. Okay, so you need to know what is inode. Okay. Okay, some structure, some function, some long um starting pastime. Okay, so my function, right, was my VTF. Okay, it's some function. Um, okay, anyway, we do this function, does it all. Okay, and this one is basically okay. So I think those globals are defined by this function, and then we what we do regular files, numbers of regular. Okay, so basically it counts as just those all stuff. Full pass, and it calls it recursively, right? No? Okay, it calls do pass, right? And do pass is probably calling itself. Hmm, realloc. Okay, I like realloc. What is realloc? Realloc. Okay, it's memory stuff. Um, okay, so we're returning do pass, and I accept do pass is executing itself, right? Or no? Okay, so it gets directory, it gets its stats, blah blah blah. If it's not, it returns. If it's a directory, basically, um, yeah. So this is the main cycle, sorry, loop, which is going through those two stuff, blah blah blah, and basically, yeah. So basically, it fetches the. No, it doesn't. Func. What does the func mean? What does it call itself? We actually don't do anything here. What is it? Full pass. Okay, don't say that I'm using full pass here, okay? Don't say it. Okay, I'm using a global variable called full pass. No? What do you mean by no? Full pass. Full pass. What is full pass? Where is it defined? Don't say this is a function. It's not. Okay, guys, we need to understand what is full pass. We need to find this declaration of this stuff. Oh my god. Full pass, full pass, full pass. I don't see full pass, guys. Oh my god. Okay, yes, so it's global variable. Okay, so basically we modify global variables and we execute it. Yeah, okay, it's understandable. So every time we call this function is analyzing this pass, and I guess it's adding it, right? No? Okay, but yeah, but here we execute func, and func is my func. No? Oh my god, too hard, guys, too hard. My func, static, my func, my func. Oh, okay, yeah, it's a function. Okay, nice. Yep, so I think we understand, right? So here we call, so for each file we call our function, and our function is this function. Basically, it is choosing which file it is and counting it. Pretty easy, I don't know. Change dir, I think it's easy. Change dir to TMP, blah blah blah. PVD, we execute, we yeah, but we did not end up there. Okay, we can get, understand. Um, okay, so we try to change gears and we allocate some stuff. Um, okay, and we get okay. No, if define Solaris. Okay, so if you're working on Solaris, probably you're using this every day, right? Okay, guys, I propose to wait for 1 hour and I will finish it to be equal 1 hour, okay? But I will do another video just after that. Okay, so we define some stuff. We get some stat. What do we do? We get some stat. We print measure. Okay, so from this stuff we get some stdef. We get some measure minor. I don't know what is it, but it's probably something minor measure manage device number. So yeah, so we just get this minor and major stuff, and this is related to devices. Maybe you remember. I remember it when I was creating a device with a driver. Okay. Okay, so now we're checking some stuff. Block device, char device, blah blah blah. So here we pass some device. Okay, here we are passing basically two devices. That's all right. Oh yeah, nothing special, right? Block, char, character. This one is block. Mount. Okay, nice command. Okay, we have summaries. We have some flags. Ooh, God. What is F5? Okay, white oriented. What is white oriented? What is white? I don't know what's white. Performance depending on the value. Okay, if the motor argument is negative, white will try to make specified stream byte oriented. Byte oriented, but it will return streams orientation. Oh my god. Okay, I don't know what it is, to be honest. Set mount, set when buffering. Okay. If we don't like those defaults for any given stream, we can change the buffering by calling setbuff or so there is some default buffering and we so yeah, so buffering is, I think you know that it's not passing everything by bytes but saving it to some buffer, and we can change it. Also we can flush the current buffer into the device. We can open a stream, of course. What? Okay, anyway, it's some sort of opening, right? Yeah. Okay, it's something to stream. Okay, this is easy. Easy. What? What does it mean, pushback characters? How you push back characters? Okay, man, I just want the ones that I provided, okay? Not everybody, okay? Pushes back to stream cast on center where it is. What the- Okay, guys, I don't have an idea. I need an example. Why didn't you provide just examples? I mean, without examples, we cannot work it out, sorry. Okay, so we just get charts, we put them, okay, here we get, also we get something, we put it, okay, why so easy, guys, can we give me something more cooler? Okay, pretty obvious. We already did it, what is rewind, I don't know, but, God. Okay, man, as I said, I just want this completely, this specific command. Um, okay, so very, very useful. Tell all returns. Okay, it sets right. Get pause. Okay, so it's like replaceable. Okay, some formatting. Okay, guys, I will not dive deep in the specifics, but some formatting. Okay, so this is just into some buffer. No, easy, easy. Okay, I will. Formatting is obvious. This is scanning with formatting. No problem. I don't know, another scanning. Again, I need examples, sorry. Okay, we have some function, we have some another function. So we ask for blah blah blah. We get something, one line to standard. Okay. Okay, now we execute our functions. Okay, we open some file, we get something out of file, uh, and we do some function. Yes, we get the stream. Stream was on a buffer. What is in buffer? Okay, it's our own. So basically we call our own function. Okay, and basically what it does is just oh my god, how easy it is. Where is it? What is minus? Ah, okay, it's length, right? Oh my god, I am so cool. Okay, guys, I will count down because it will be like 1 hour. So, okay, guys, um, put a like, subscribe, share this video among the world, leave a comment, and we are finishing in 54, 55, 56, 57, 58, 59.